9-4, slope. In this section, we're going to be investigating the slope of a line. So any line that you draw is going to have a slope to it, whether it's flat on the ground, straight up and down, vertical. Any angle that you draw a line at is going to have a slope. So let's look at what the definition of a slope is. Okay. Slope. Slope is the ratio. Remember what a ratio is, okay? A ratio is a comparison of two numbers by division. 1/2 is a ratio, 1 being compared to 2, 1 divided by 2. So slope is the ratio of the rise, which is the vertical change, that's the change going up and down, run, which is the horizontal change. Horizontal is back and forth. Okay, so let's put this in here a little bit more colorfully. There. So slope is the rise over the run. All right, let's do an example then. Let's do example 1 on page 481. And it says, find the slope of the treadmill to the right here, okay? So our slope, we know so far, it's defined as the rise over the run. Okay, well, let's see. We go over here, and this 10 inches right here, this is the rise. The 48 inches right here, this is the run. All right, so we just come back and we plug these in. So the rise is 10 inches over the run, which is 48 inches. All right, so this becomes, let's see, we can do 10 over 48. We can take out a 2 from both of them, and this becomes 5 over 24. You will notice 5 over 24 does not have any units. The inches cancel, so slope does not have inches. Therefore, our answer is 5 over 24. In the previous example, we calculated the slope because we were given the rise number and the run number, 10 inches and 48 inches. In this example, example 2, on page 482, we're given this graph here, points A and B, and we need to find the slope of the line that connects those two. Okay, so again, our slope equation is the rise over the run. Now, what is the rise? Well, we go over here to our line, all right, right here, and we look at point A, and point A, we look at it and we go, what do we need to do to get to point B? All right, we need to go up 2, 1, 2. We need to rise 2. Now we're on the same line that B is on, the same Y line. Now we need to go across and do the X and find the X value. How many steps there are. So there's 1, 2, 3 moves that we have to move to get to the B. So we rise up 2 and we run 3. Okay, so back over here then, the rise is we rose up 2 and the run was 3. So this is how you find the slope of a line on a graph. You can do it by counting. Okay? All right. Okay, let's do example 3. Example 3 says This is finding slope using a table. And it says the points given in the table lie on a line, find the slope of the line, and then graph the line. Okay? So we look at the table here. Now remember back when we were talking about linear functions. And the test for linearity was whether the x's and the y's changed by the same amount. Not same to each other, but same to them, same to the each x and y, but same to each x and y. So from 1 to 3, that change is what? That change is plus 2. From 3 to 5, that change is plus 2. From 5 to 7, that change is plus 2. Looking at the y's then, from 12 to 9, what's that change? That's right, minus 3. From 9 to 6, again, minus 3. And from 6 to 3, minus 3. All right? So over here then, we're going to have a slightly different formula for slope. Okay? We're going to introduce a variable called m. And we're going to say now the slope can be calculated by the change in y over the change in x. So how much y changes over how much x changes. Now remember, y goes up and down, vertical. X goes back and forth, horizontal. All right? So let's pick two of these numbers. Okay, the change in y. What is that? Well, we went from a 9, we went from a 12 to a 9, because y, this is how you make change, or how you calculate change. And for the x's, we went 3 to 1, 1 to 3 going the other way here. All right, so 9 minus 12, the change in y then was negative 3. Now remember, this is the change in y. Don't be confused by the table, the fact that x is on the top. Okay? Here y is on the top, because that's our formula. So don't let that confuse you. And then 3 minus 1 down here on the bottom is 2. So our slope, then, calculated from the table, is negative 3 over 2. So let's plot this. Over here on our graph, this is the y-axis, and then way down over here is the x-axis. Like that. So, scrolling up just a little bit, we look at our table, and we say that x is equal to, when x is 1, down here 1, y is equal to 12. Well, there it is right there. When x is equal to 3, 1, 2, 3, y is equal to 9. Right there. When x is equal to 5, then y is equal to 6. Right there. And finally, when x is equal to 7, y is equal to 3. Right there. So let's plot a line. Like so. So there is our line plotted, and all of those points correspond to the points that are up in the table. So we're going to give a little table here, a few tips and tricks about translating rise and run. Okay. So translating rise and run. All right, so if something is going up, then it's moving in the positive direction. Okay? If something is going down, then that is in the negative direction. If something's moving to the right, okay, that is in the positive direction. If something is moving to the left, that is in the negative direction. All right. Okay, so far you have found slope by looking at the actual rise of an object over its run, like the treadmill. And you've also found slope by looking at the change in y over the change in x. Okay, that was from the table, and also from 2 points on the line. Now, in this case, what we're going to do is we're going to give a general definition of slope given any 2 points that you've got on a line. Okay, so the first point will be, according to our diagram here on the right side, x1, y1. The second point will be x2, y2. Okay, so then we can write a formula that says that the slope, m, remember this is the variable for slope, m is equal to the change in y. So we take y2 minus y1 over x2 minus x1. All right, and that's it. All right, where obviously you can't have both x's be the same, otherwise you would have divide by 0, and you know the results: big hole in the city, smoking, burning, disaster, end of the world, that kind of thing, badness. So no, divide by 0. All right, now let's do an example of this. All right, let's do example 4. That's on page 483. All right, and it wants you to find a slope of the line that goes through these 2 pairs of points. C, which is at -1, -4, and D, which is at 2, 2. All right, now what I recommend that you do is you assign these points to your x1, y1, x2, y2. It will help save time. It will avoid confusion in the future. It's a good habit to get into. Okay, so over here I'm going to put x1, y1 is equal to c, which is -1, -4, and then x2 y2 is equal to point D, which is 2, 2. Now, does it matter which points go with which x1, y1, x2, y2? No, it does not. As long as you do your math correctly and hold to PEMDAS, you will get the right answer. Okay, so let's look at our slope formula again. M is equal to y2 minus y1 over x2 minus x1. Looking back now at our points, y2 is 2 minus y1, which is -4, over x2, which is again 2, minus x1, which is -1. Okay, so 2 minus a -4, you should get 6. 2 minus a -1, yes, you should get 3. Therefore, the slope of this line is 2. Let's do another example. Let's do example 5. It's example 5 on page 483. Same deal. We need to find a slope of the line passing through these 2 points. Point R, 1, 2, and point S, -4, 3. So again, I would allocate these points. So x1 comma y1 is equal to r1 comma 2. x2 comma y2 is equal to s negative 4 comma 3. Again, it doesn't matter which one of these you assign to which. It will work out the same. So our slope formula is m is equal to y2 minus y1 over x2 minus x1. And now we substitute in y2, which is 3, minus y1, which is 2, all over x2, which is negative 4, minus x1, which is 1. 3 minus 2 is 1. Negative 4 minus 1 is negative 5. So our slope then is negative 1/5. Okay, thank you for watching. If you would please comment it down below so that I know who has watched this video. I would appreciate it. If you care to like it, that's great. If you don't, I'm not going to be hurt. And I will see you guys soon. Bye.